Hello, in this video, we will introduce depth-first search. The depth-first search of a graph is like the depth-first search of a tree. In the case of a tree, the search starts from the root. In a graph, the search can start from any vertex. A depth-first search of a tree first visits the root, then recursively visits the subtrees of the root. Similarly, the depth-first search of a graph first visits a vertex, then recursively visits all the vertices adjacent to that vertex. The difference is that the graph may contain cycles, which may lead to an infinite recursion. To avoid this problem, you need to track the vertices that have already been visited and avoid visiting them again. The search is called depth first because it searches deeper in the graph as much as possible. The search starts from some vertex V. After visiting V, visiting an unvisited neighbor of V, if V has no unvisited neighbor, backtrack to the vertex from which we reach V. So let's look at this example here. So we're going to start from vertex 0. You can visit 3, 2, 1 in any order. So let's visit 1 now. So visit 1 now. And this is the 1 now. From 1, you have 0, 2, and 4. Now 0 has already been visited, so you can visit now 2. For 2, you can visit 0, 1, and 3. So 0 and 1 already visited, so you have to visit 3. Now from 3, there's no more unvisited vertices. So you have to go backtrack right here. And 1, you can go to 4. And now you go backtrack and backtrack all the way to 0, and there are no more unvisited vertices. So this is the depth first search. You can use this algorithm now to describe depth first search. This is the graph with vertices and edges and a starting vertex V. The output is a depth first search tree rooted at V. So for this depth first search starting from vertex V, first visit V. For each neighbor W of V, if W has not been visited, so now you're going to set the parent of W to be V and recursively invoke depth first search on W. So let's look at the implementation of the depth first search. So here in the algorithm here, this is the algorithm in this listing 26.5. And now let's look at the code for the depth first search. So this is depth first search. This is the search order, and this is the parent initially, and all this parent, this is -1 means we don't know it yet. So we're going to mark the vertex, the starting vertex V is visited. So this is the, and here is visited. So this is visited. So let's use this is, here is visited is, this is the Boolean is visited. So the size of this is vertices.size. And this is all false. So this is all false now. So here is using this for loop to initialize and all this vertices. So this is to declare is visited to track all visited vertices. Now we recursively invoke depth first search. So this is the helper function. So starting from this this V, so we're going to visit V. Now using this parent here, search order is visited. So this is the depth first search. So we're going to search this, push back this V to search order is visited, or V is true now for every edge of this neighbor's V. So we're going to look at the W here is there's two vertices in E is U, V. So this V, if this is not visited, W is not visited. So we make V as the parent of W, recursive invoke DFS, and here is W, and this is the parent search order is visited. So after this is all finished recursively, and this we're going to create the tree using this V as the root, and here's the parent and search order. So let's write a test program using DFS. So we're using this graph, the vertices of the cities and the edges, and now creating this graph here using the vertices and edges, so the number of edges. And now starting this, search from vertex 5. 5 is index for Chicago. And now is this is we're going to get all the vertices. So display and get this tree here, DFS, get search order. So display all the vertices in the search order. So this is all the vertices in the search order right here is displayed. So next we get the parent for each. So the parent for Seattle, the parent for San Francisco. So we get all the information here. There are many applications for depth first search. The depth first search can be used to solve many problems, such as the following: detecting whether a graph is connected, search the graph starting from any vertex. if the number of vertices searched is the same as the number of vertices in the graph is connected. Otherwise, the graph is not connected. Detecting whether there's a path between two vertices, finding a path between two vertices, finding all connected components. A connected component is a maximum connected subgraph in which every pair of vertices is connected by a path. So that's connected component. Detecting whether there's a cycle in the graph, finding the cycle in the graph. You can look at the program exercise and for the applications, the programs, and using all these applications of DFS. That is all for this video on depth first search. See you on the next video for breadth first search.